Hello! So, today we start to explore the guide of 42, the tutorial, chapter by chapter. So, today we are going to see chapter 1, basic concepts. As you can see here, there are some chapters, we will see them one at a time. And this is a tutorial for people that already know how to code and they want to transfer this knowledge to be able to code on 42. At the start, it's explaining you how to download 42, and we have seen this already in the former video. And instead now we're going to focus on the basis. So, to have an hello world in 42, you first define which towel do you want to use. And the idea is that in 42, there isn't a single standard library. On the opposite, the programmer can choose a library of their own choice to be their standard library. And this standard library this towel should contain typical classes for string, number, booleans, exceptions, data types, collections, and so on. And the beautiful bit is that it's easy to define your own towels. And we will see it quite late in the guide, because of course it's quite of advanced material, but you can define your own standard library by twisting and tweaking the default one, for example. And so you can adapt the default standard library to serve you better for a specific kind of application. And then we have a main, in this case called main, but you can call it as much in any way you want. And this is just doing debug hello world. And it's a little bit different from what you may expect in other languages, because debug here is a class name, and we are calling a method on the class name without giving a method name. We are not writing debug.println, we are just writing debug. And that's because the main functionality of the class debug is to print out. And so the default method of debug, the method without name, will just print out. And to call the method without name, you just write debug, open parenthesis, and the argument. And the argument hello world, what is this? This is the type of the string S. And in other languages, usually you don't have to put it there. Also because in other languages, usually there is only one string type that is summoned by this spatial syntax. And this is not happening in 42. In 42, you can define your own string classes, and Adam Towel have many already inside. And you can define different string type for different situations and different cases. And so you have to specify which string do you want to use. And number literal are exactly the same. You cannot just say 20. You have to say 20 what? 20e, 20i for 20 index, 20 num for 20 number, and so on. 20 float, 20 double. And then we can see an example of just a very, very, very simple class with a single class method. So we can have a class myCode with a single class method that is like a static method in most languages, that is called hello, returns a string s, and take a parameter of type s nickname. And inside of the method body, you can use the most usual statements. And so you can write if nickname dot is empty, return hello. Return hello percent nickname if you didn't enter in the if. So the percent is the string interpolation in 42 and allows you to put the value of the parameter nickname here in the string. The string interpolation in 42 is more flexible than in most other languages. So for example, I could write .size to print here not the nickname but the size of the nickname. So I can put any chain of method call and it will work with the string interpolation. And then we can call our code. So I can make main equal debug of my code.hello nickname equals string Marvin. And here you see it's different from what you may expect in another language, where you will not expect to have to write down the name of the argument. And so in 42, when we call methods, we explicitly pass the name of the arguments. There is an exception. An argument called that is like the predefined argument. So if the first argument of a method is called exactly that, you can omit it when you call it. So in this way, 42 tries to reserve some names and some concepts for the predefined things, so that you don't have to necessarily name absolutely everything. So the most important method, you can just use the method without name, to not have to figure out yet another name for this concept, because probably the class name is enough. It already qualifies enough what you're doing. You're doing the most important thing that this class is doing. And same for the parameters. The first parameter can be called that, so that you don't have to repeat the name of the parameter that otherwise will specify what's the role of this point of information inside of the method execution. If the role is the most important role, you can just call it that, and you can avoid to specify the name when you call it. Giving good name to things is a difficult aspect of programming, and so 42 tries to avoid you having to give names to things when it's not needed. On the other side, giving the name explicitly of the other parameters, we believe it really increases readability. Imagine that you have, typical examples where you take an x and a y coordinate and you never remember in which order you are taking them, or something like that, It's very easy to make a mistake and pass them in the wrong order. If you have to write explicitly x equal and y equal, then your code is much more explicit in what it's doing when you are trying to read it, because the parameters will tell you what's the role of that element into the method execution. Now let's try to make a simple class with internal state. So here we have point, and we declare two fields, x and y, and we define a method add and another method add and a method sum. Now usually to define two methods with the same name, you will have to use overloading and the arguments will have to be of different types. But here there is exactly one argument with the same type. However, the argument name is different. And so this is an advantage of the fact that we have to always pass the argument name when we call the method. The method actually is selected from not just the method name, but also the name of all of the arguments. In this way, we can have two methods called add. One is actually called addX, and the other one is actually called add_y. And so you can have a method add_x that add an x, and it's doing it by creating a new point. And what's the main method of point? The factory method that creates new points. And so point, where I take two arguments, one for x and one for y, with their role explicit x and y. And so point of x equal x plus this dot x, and y equal this dot y. And so those are getters, and they are automatically generated by writing the field. Or if you prefer, the field in 42 really are just the getters. And we haven't declared a constructor or a factory explicitly. And here we're using this with method that I will explain in a moment. But again, we are not declaring it. And this is because data is taking input this code between balanced curly bracket, and it's taking it as a suggestion. So this class point is not going to have two fields and three methods. It's going to have a lot of methods to make it easier to use this class. Data look to what are all the fields in our declared chunk of code that we pass to data, and it uses this information, what are the fields, to build a more complete and more usable class. And so one of those methods that data generates is with. And so since we have two fields, it's going to generate with x and with y. And the with just behave like line 6. So you can write line 6 in a longer version, or you can just write this dot with y equal y plus this dot y. And the value for x is going to be took from the current point. So the withers creates a new object that looks like the old one, but with some difference. In particular, one field is going to have a different value. And then we can have a method sum that takes another point and call it that, so that we can just pass it without specifying the name of the argument. And it's creating a new point where x is equal this dot x plus that dot x, and y is equal this dot y plus that dot y. So this idea of data is actually one of the most important features of 42. It's called a decorator. And a decorator is just a class or an object that offers the operator colon. And the operator colon just takes some code and produces better code. What do we mean by better? It produces code that is better according to the decorator. So the decorator object, in this case data, decides what does it mean to be better in this context. In this case, data will improve the code by adding a lot of useful auxiliary methods that let you work better with the state, like the withers, equality, hashcode, factory methods, toString. And now the backslash. So the backslash, it's a way in which 42 is syntactically quite different from other languages, but it's just a syntactical trick. So there is not like anything complicated behind the slash. It's just a way to have some inference so that you can write less code and some boring detail can get sorted out for you. So in particular, there are two kinds of uses for the slash. There is the slash on its own as a keyword that is just the expected type. And then you can have the slash with an identifier directly after that instead will represent a method call. So here we can see the slash as a type. I can implement my method add that have to return a point by writing point of x equal x blah blah blah. Or since we know that this method returns a point, we know that the expected type is point. So I can just write slash. And same, if I want to write a method foo that has to return a number, I can write 1 slash instead of 1 num. Or I can write 1 slash plus 2 slash. So you don't need to just return directly the result of what you're using the slash for. The slash simply represents the expected type, and then you can use it, you can call methods on it, you can call more operations around it, and you can do what you want with it. In particular, here, I show a very tricky example, maybe it should not be in chapter 1 in the guide, where we want to return class num. So class num is the concept of num. So it's the object that represents the class number. And since the expected type is num, I can just write slash, because slash will be expanded in num. And everywhere, if you just write the name of the class, you are talking about the object that represents that class. 42 is a pure object-oriented language, so everything is an object, and so classes are object, and every method is called on a receiver. So a class method is simply a method called on the class object. This is different from example from Java, where when you call a class method, yes, you write the name of the class dot, but what is on the other side of the dot is not really a receiver, it's not really an object, it's just a convention to call the static method. In 42 instead, the class object is the receiver for the static methods, and you can pass the class objects around, and sometimes it's very useful. And we will see some example of that in a few more chapters. Another interesting example, I can have a method return num called buds, and so I write slash, and this is just num. So slash dot 0. So I'm calling the method 0 over num, so I'm getting the constant 0. And then I call dot to string, and this is returning a string, but aren't we returning a number? Isn't the slash supposed? Yeah, the slash just represents the expected type, that in this case is number. And then you can call a chain of method over it, no problem. And so this is number, this is a number, this is a string, and then I call dot size, and I get a number back again, and so this method actually works, and it's probably returning 1, because 0 is composed by 1 character. Now, another use of the slash is for representing a method call. So we have seen the method add, where I was doing this dot with y equal y plus this dot y. We can shorten it with a slash, and we can just write this dot with y equal y plus slash y. And the reason is that this is a method, the receiver is this, so the slash with the identifier represents the receiver. So this is equivalent of writing this again. If you have a bigger expression where you are calling many methods chained one after the other, the receiver, maybe you don't have it in a local variable, and so it may be very convenient to use the slash. This particular example, we can even write it a little bit shorter by putting a slash also here. Because at top level, we are inside of this method of this, and so I can use the slash as this at top level. Here I'm showing another example where I have a point and I can write that.width y equal slash sum. And this slash expands to that, because that is the receiver of this method. What's the receiver? The receiver is the thing before the dot. Terminology. I know it's boring, but it's important to be able to talk. The receiver is the thing before the dot. And so here, there is another method call for y, and this whole thing that I've selected, it's the thing before the dot. So it's the receiver of that method call y open close. Now, I have ready a little graphical representation of the slash. So here you have that's the slash. Beautiful, isn't it? Now, the slash in 42 is actually two different syntactical concepts depending on how you use it. So you can have the slash on its own that just represents the expected type, or you can have the slash hosted, with something attached after. So this is the slash with some identifier after. And this is now the most powerful feature, the most defining feature of object orientation, a method call. And the slash works when you have complex method call expressions. So you have, as you can see here, a method call, that.width, and inside this method call, to create the parameter to pass to this method call, to satisfy this method call, we use the slash sum. So slash sum. And we are using the context of the call, that is that, to complete the call that we are doing. So the receiver can help us to generate the value for the parameter for the method itself. It turned out it's exceptionally useful. We will see a lot of examples going forward with the guide where it's so convenient to be able to refer to the receiver when you are trying to generate values for the parameter of the method call. So, next point, how do we make collections in 42? So, we of course have a library class called collection, and we don't have generics in 42. So if you have never really liked generic, yay, no generics in 42. Every class is concrete, and every type is just the type name, maybe with a little keyword in front to specify how you can use it, but the types have a bounded complexity, so they will never get a map of the string into list of point, You always have to give a name to your type, so you can have collection.list of num, and then you give it a name, nums. And so nums is going to be a list of numbers. And you can say points is collection.list of point. And so now you have a list of point. And you can have two mains here. In 42 you can have more than one mains, and they're just executed one after the other. And you can have debug, nums, and then 10 slash, 20 slash, 30 slash, because it's a list of numbers, so we know that elements are num. And same for points. Here I can have points of slash, open round, x equal 10 slash, y equal 20 slash, 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 slash. You see, we are starting to use slash everywhere, and it will be so much longer without the slash. And of course, into a list of point, what you're going to put in? You're going to put points. So you don't need to repeat point, point, point. And when you create a point, the two coordinates are numbers, so you don't need to repeat num and num. So when you create a very nested data structure, the slash becomes very useful. With the generics, as you may have seen in Java, C#, they denote a type. So if you write twice a list of string, they are the same type. In 42, since you give a name, they are generative. So here we are generating a type list twice, and we are giving it two different names. So here we are calling it nums1 and nums2. And those two are going to be two different incompatible nominal types. And this is actually very convenient, because it means that if you want to use different kind of lists for different reasons and you don't want to accidentally mix them, you can just give them different names and they will be different incompatible types. That is, you can rely on the type system to prevent you from doing stupid bugs. Now let's make a little example with a for, another staple of programming. In 42, the for loop is a little bit richer. So here I'm showing you something interesting where you have a XS with numbers 10, 20, and 30, YS with numbers -1, -1, 2/3, and 3. And as you can see, if you have to define a negative number or a fraction, you have to use the string literal syntax. So the string literal syntax is not about strings or numbers, it's just a syntax to create value from characters. And you can use it for strings, you can use it for numbers, and many other kind of data types, and it's very useful. And then we make an empty list of points. And then we iterate for x in XS and y in YS. Whew, it's different, you see? Usually you will expect to iterate on a single thing. In 42 you can iterate on as many collections as you want, and you will do a parallel iteration. So here both XS and YS have 3 elements, and so we're going to do 3 rounds of iteration inside of this for. And so for each round of iteration we are going to do points.add, so we're adding a new point to our list of points. And I can use the slash because of course we are adding points to a list of points, x equal x, y equal y. And then I can do the bug points. And notice how we haven't wrote any toString ever, but data is generating the toString for the point class, and the collection is generating the toString for the collection type. And so we have our perfectly readable printout with our 3 points. Whew. So, concluding, we have seen a little introduction of the most basic syntax, and we have created various kinds of objects. And in 42, to create an object, you usually write down the type of the object that you are creating, or you use the slash to just make it inferred. So we have seen that you can write 12 num to use to have just a bunch of digits and create a value out of it, or string foo for a much more rich set of alphanumeric characters, or you can just call a factory with point. And this again is just a method call. So data is creating a class method inside of point that creates the object. And for the collections, or in general, any method call where you don't know the number of arguments, we use the square brackets. And so you can write points and pass the various elements separated by semicolon. So in the end of those sections, sometimes there is this digressions expansion section that is like a little bit more complicated, and it's something that maybe you can read after you have read all of the chapters, you know, so he's talking about this chapter, but making connections, you know, maybe with other chapters, and try to tie the whole 42 language cohesively together. Okay, so this is the end for today. See you for the next time where we are going to see section 2.